Hello, everyone, and welcome to the Varsity Tutors StarCourse series, where for all things magical and mysterious, we're going to be turning to the world of alchemy today with our friends at the Science History Institute. And in today's live class, we'll be learning about how alchemy is borrowed from both chemistry and mystery throughout history to make amazing and seemingly magical things happen. And along the way, we may even get to make some seemingly magical things happen ourselves with today's live experiment. Now, before we get started, just a few quick things to keep in mind. We're going to have the opportunity to transmute in today's live science experiment, and I won't give away what that is just yet, but there are a couple of things that you'll need to be prepared with. You'll want an old penny, the older the better, as well as salt, vinegar, and a bowl. If you don't have them handy right now, not to worry, you're welcome to watch the magic happen today and check out the recording to try it yourself. You'll also want to be sure that you have a camera close by, because toward the end of the lesson, we're going to have the opportunity to lean into the screen and pose for a selfie, possibly with your experiment results if you've been following along. And if you post that selfie on Instagram and you tag us and the Science History Institute, you'll be entered to win a pretty cool Science History Institute swag bag, as well as enrollment for one to a virtual summer camp of your choice. You'll also want to be sure that you keep in mind during this live lesson that we are very open to questions and that we'll have some questions for you as well. So feel free to use the chat on the right-hand side of your screen to both ask and answer questions throughout the lesson. If we don't get to those questions right away, not to worry, we're going to save about 5 or 10 minutes toward the close of the lesson specifically for Q&A. And with that, I'm going to go ahead and hand things over to your instructor for today with the Science History Institute, Megan Allen.
Hi guys, I'm so glad you're all here with me to learn about the science of alchemy. As Haley said, my name is Megan and I'm going to be your instructor today. So I work at the Science History Institute, which is a museum and library in Philadelphia. We study how scientists work today, but we also study how scientists worked in the past. To those of you who have taken our courses before, welcome back. And to those of you who are new, it's great to meet you. So let's get started. So to get us started, I'd like you to think about what pops into your head when I say alchemy. So we're going to start off with a pop quiz, but don't worry, no grades, just fun. So what is alchemy? Is it A, a kind of magic that witches and wizards do? B, a new TV show on Cartoon Network? Or C, an early type of chemistry? This is a tricky question, so I'll give you a minute to think about it. All right. Now I'm starting to see some answers come in. It's great. But I'll give you a few more seconds to think. All right, some people are saying A, some people are saying C. Not a lot of you are choosing B. Most people are saying A and C. That's good. So let's go ahead and eliminate one answer. Can we all agree that it's not B? Alchemy is not a new TV series, although it would be a pretty cool TV series if it were. So we're left with A and C. Which do you think it is? Raise your hand if you think it's A. All right, I see hands, that's good. Raise your hand if you think it's C. Okay, we're about evenly split. If you chose C, congratulations, you're right. Alchemy is an early type of chemistry. So what does that mean? And why isn't the answer A, even if our class is called The Magic of Alchemy? So when we think of chemistry, we probably think of the periodic table of elements, right? Chemistry is the study of how the elements work together. On a more basic level, chemistry is the science of stuff. It's the science of how things are formed, how things decompose, how things break apart, and just how things change generally. There are certain rules that govern chemistry. We know that elements always act in certain ways. We know that if we combine one oxygen atom with 2 hydrogen atoms, we'll get a water molecule. Alchemy has these rules too. Even though the alchemists didn't know what the elements were, they knew that certain things would react in predictable ways. And there are rules that govern the way nature worked. And this is why, and magic doesn't really have these rules. Magic, anything can happen, right? Like in Harry Potter, anything can happen. So magic doesn't have these rules, and that's why it's magic. So we can say that alchemy is an early type of chemistry before scientists discovered what the periodic table of elements was. It's a chemical science. So let's get started with the history of alchemy. Now that we know alchemy is early chemistry, let's go into more detail about what that means. So how long do you think that people have been doing alchemy and chemical sciences? Raise your hand if you think that people have been doing it for 100 years. I see a couple hands. Okay, I see some people not so sure. Raise your hand if you think people have been doing it for 500 years. All right, we've got a few more hands. Yeah, it's pretty old. 1,000 years? Anyone think we've been doing alchemy for 1,000 years? Yeah, couple hands. Anyone think we've been doing it for 2,000 years? Yep, I see a few hands up, and that's right. People have been doing alchemy for about 2,000 years. Some of the earliest records we have of people doing alchemy date from the 4th century. These recipe books are called the Leiden and Stockholm papyri, and they were written in Egypt. They were written on papyrus, which is a type of paper that the Egyptians made using flattened reeds from the River Nile. And these recipe books are now in museums in Leiden in the Netherlands and Stockholm in Sweden, which is where they get their names from. And here on the screen, you can see a picture of an Egyptian papyrus and a hieroglyph or Egyptian drawing of people writing on papyrus. Now, these are just the earliest records that we have. People could have been doing alchemy and probably were doing alchemy long before then. It's just that none of the documents from those periods have survived. But we have evidence, written evidence, that people were doing it almost 2,000 years ago. So what kinds of things do you think people were using alchemy to make? And just pop those into the chat or shout it out. Let the world know what you think alchemists were making. All right. I see some people are saying they were probably making medicine, maybe makeup. I see a lot of people are saying that they were making gold. And that's right. When you think of Egypt, you think of pictures like this, right? Egyptians always had great jewelry. They're kind of known for their jewelry and their precious stones. Well, Egyptian alchemists were really interested in making jewelry, but without using pure gold or real stones. Instead, they would try to plate metals with gold. So they would take a cheaper metal that was lighter and they would cover it with a thin layer of gold. They also sometimes made imitation gold, where they would take other metals and they would dye it yellow so that it looked like gold and it shined like gold, but it wasn't actually gold. They also really like to use gemstones, but gemstones are hard to get. And so they would take glass and they would cut glass to make it look like a gemstone, and then they would dye it different colors. So they would try to mimic real stones like rubies and sapphires, but with glass, which was much less expensive. So that way everybody could have jewelry. Another cool thing that they were doing at this time was creating dyes for fabrics. So raise your hand if you have tie-dyed a shirt before. Anyone tie-dye shirts? I have tie-dyed a lot of shirts. When the Egyptians wanted to color their cloth, they would have to dye it. And so the alchemists were making recipes for dyes. And you know how sometimes, well, when you tie-dye a shirt, you have to set it, or else when you wash it, all the dye will run off. The Egyptians were trying to discover ways to make their dyes stick to the cloth. So this was a really big industry. People were trying to figure out how to make cloth stay dyed to maintain its color. Now, these early alchemists, they didn't think that they were actually making gold. They thought that they were just making metals that looked like gold. But an important change happens around this period, the 4th century, when we have these documents from. At the time, there was a lot of cultural exchange between Greece and Egypt. And so the Greek philosophers all were very interested in matter, the stuff that makes up the world. They wanted to understand what it was, how it acts, why it acts the way it does, basically the same as modern chemists. So the Egyptian practitioners began to incorporate these Greek theories about matter. And they began to think, well, maybe we actually can change one metal into the other. Maybe we can transmute one metal, change it into something else. By the end of the Roman Empire in the 5th century, a lot of scientific materials were translated into Arabic. These Arabic scientists not only translated alchemical works out of Greek, but they also wrote their own, and they made even more theories to explain how matter behaves. Works on alchemy became so popular that people would even write books under the names of famous authors like Aristotle. We have alchemical texts today that were supposedly written by Aristotle and other famous Greek authors, but were really written in this period by Arabic authors. And if you think about it, it makes a lot of sense. You know, if you say that you have a book that was written by a very famous author, people are going to be more interested in reading it than if you say you have a book that was written by somebody that nobody's heard of. So one of the famous authors from this period is a man named Jabir ibn Hayyan, and he's the man here in this picture. And we don't know a lot about the actual person, or even if he was real, but we do know that for over 100 years, between the years 850 and 1000, people were writing books on alchemy and attributing them to Jabir. Because there were so many works written by so many different people, all under the name of Jabir, we usually refer to this group as the School of Jabir. One of the things that this school is most famous for is promoting a theory called the Mercury-Sulfur theory to explain how metals are made. According to the Mercury-Sulfur theory, all metals are made of a combination of 2 types of matter, mercury and sulfur. These aren't the elements that we know today of mercury and sulfur. If maybe some of your parents have old style thermometers that have liquid mercury in them, that's not exactly what they're thinking of when they talk about mercury and sulfur. For them, mercury is a sort of a wet matter, very similar to the element, but not exactly the same. And sulfur, again, sulfur isn't the sulfur element that we see on the periodic table. It's more of a dry matter, like a dry powder. And so mercury and sulfur combine in different ratios to form the different metals. And these people believed that all of the metals, all the differences between metals, could be explained by having different amounts of mercury and sulfur and how pure the mercury and sulfur were when they started. So if the sulfur had bits of other things in it, maybe wasn't very pure sulfur, then you wouldn't get a very good metal in the end. You would get something like lead, which isn't as nice a metal as gold. So they thought that all metals came from these 2 principles. And this is important because this meant that alchemists thought that they really could change one metal into another just by adjusting the ratio of mercury to sulfur. So far, we've talked a lot about using alchemy to transmute one metal into another. But can you think of any other things that alchemy might be able to do? Do you think that maybe it could help make medicines? Because that's exactly what it did. So in 1144, a man named Robert of Chester translated the first book on alchemy into Latin. At this time, a lot of books were being brought back and forth between the Middle East, where people spoke Arabic, and Western Europe, where people spoke Latin. Beginning with Robert of Chester, lots of people in Europe began to translate the Arabic books on alchemy into Latin so that more people could read them. Now, just like the Arabic authors took the Egyptian alchemical books and made more theories about how alchemy would work, like the Mercury Sulfur theory, European authors borrowed the Arabic writers' theories and made some of their own. So what was included under the domain of alchemy starts to grow, and there are more theories to explain why matter behaves the way it does. A lot of these alchemists continued to use the Mercury Sulfur theory to explain how metals were made, but they also started to apply alchemy to other things like medicine. European alchemists realized that alchemy could make a better medicine in a number of ways. So the man on the screen here is Roger Bacon, who was one of the first people to connect alchemy to medicine in Western Europe. And Roger Bacon lived in the 13th century. He lived from 1220 to 1292, and he was right in the age when a lot of the books on alchemy were being translated from Arabic into Latin. So he's really right at the period when a lot of new information about alchemy is coming, and people are really starting to develop their own ideas of how alchemy could work. So remember that the alchemists were originally craftsmen, so they knew how to purify materials and recombine them, a lot like what chemists do today in the laboratory. Bacon thought that if alchemists could purify metals, then maybe they could use the same ideas and purify medicines that people were taking, which would make them a lot safer to use. Now, in the Middle Ages, most people made medicines out of plants. People like Bacon thought that alchemists could also make medicines out of metals. So today we know that eating metals is not a good idea. Please don't. But there are some medicines today that still use metal. So some medicines that work on sore joints actually contain small particles of gold because it reduces inflammation. So in some ways, the alchemical idea of using metals in medicine has carried on even into the present, but in a different way. So who here has heard that alchemists were trying to live forever? Has anyone heard that? Raise your hand. Okay, I see a lot of hands, and that's okay. So today we have lots of books and movies with alchemists in them, and these alchemists are usually trying to live forever. They're trying to find the elixir of life or the philosopher's stone, something that'll help them live on forever. Medieval alchemists like Roger Bacon weren't trying to live forever. They didn't think that it was possible, but they did think that they could live for several hundred years. So, I mean, that's pretty close, right? But you can see how alchemy has changed. Even now, we still have alchemical ideas. The idea that we can live forever. We've taken the medieval idea of alchemy as prolonging human life, and we've now made it the alchemical idea that we can live forever. So we've talked a lot about why people would like alchemy, and alchemy seems pretty cool, right? Alchemists think they can transmute metals, they can make gold, they can make precious stones, and they can make better medicines. What's not to like? But there were people who didn't like alchemy. So why don't we take a minute and brainstorm why some people wouldn't like alchemy? And if you want to share your thoughts, pop them in the chat, write them down on a piece of paper, just take a few seconds and we'll just think about maybe why would people not like alchemy? What could go wrong? You know, it certainly has a lot of good stuff. So what's a downside? All right, you guys have some ideas? Well, there's a lot of reasons why people wouldn't like alchemy. Some people believed that alchemy didn't really work, that alchemists couldn't really turn lead into gold. Even though it was a very popular theory, not everyone believed in the Mercury sulfur theory. Some people thought that metals were made out of different things, or some people thought that even if metals were made out of a combination of mercury and sulfur, the differences between the metals was too great for people to overcome, that people couldn't really purify the mercury and sulfur in a significant way and then recombine it to get gold. So you really couldn't turn lead into gold. Some people thought that the medicines alchemists made might be dangerous for people. Not everyone thought that eating metals was a good idea, right? And some people thought that alchemy could transmute metals, but wouldn't make good medicines. And then there were other people who thought that it could make good medicines, but couldn't even transmute metals. So there were lots of interpretations on how successful alchemists really were. And finally, there were people who believed that alchemists were able to transmute metals, but they thought that alchemy shouldn't be practiced, because then everyone would be able to make their own gold. Gold was used for money at the time. And if everyone could make their own gold, then everyone could make their own money. And do you know what happens when everyone can make their own money? That's right, it no longer has any value. So a lot of kings and princes who were in charge of the treasury or the money-making branch of government tried to stop people from doing alchemy so that they wouldn't make their own money. They totally believed that alchemy could work, that people were making their own gold, but they didn't want people to make their own gold and they didn't want to ruin the currency. But this didn't stop the alchemists. And alchemy continued to be very popular for the next several hundred years. This period, the Renaissance, is often considered one of the most important periods in the history of alchemy. Lots of people were interested in alchemy, and kings and princes sometimes became patrons to other alchemists. This meant that they would pay the alchemists to experiment with different metals in their laboratories. So it was kind of like a job. The kings and princes would give them a house and a laboratory that they would equip for them, and they would give them access to supplies, and then the alchemist would try to produce gold or a medicine, whatever the patron wanted for the patron. And so they were employed as their court alchemist. Now here you can see some images of an actual alchemical laboratory from this period in Prague, in the Czech Republic in Central Europe. So these are from a 17th century alchemical laboratory. So it's from the 1600s, and it's currently underground. It's being restored by the Czech national government. And so you can see lots of bottles, lots of furnaces, lots of different tools. Alchemy was always a very practical science. So even as far back as the Egyptian period, alchemists were working in their laboratories, experimenting to see how different substances would react with each other. And so here you can see where you can imagine how an alchemist or a group of alchemists or an alchemist and their assistant might be down there using the furnaces, mixing things in the different bottles, experimenting, seeing what would happen. And alchemy in this period became so popular that there were labs like these all across Europe, often funded by kings and princes. And alchemical medicine became so popular that it was even taught in some universities. So you could go to university and learn about alchemical medicine, making metals that would help the human body. So, pretty cool. Now, raise your hand if you've studied chemistry in school. Any hands? All right, I'm seeing a lot of hands. That's good, good. A lot of future chemists in the audience, maybe? Good. So now I'll ask you, why do you think we study chemistry and not alchemy in school? And I'll give everyone a minute to think, but I kind of hinted at the answer at the beginning of the presentation. But take a minute and think, why don't we study alchemy anymore? Because it's pretty cool. Write down your answer. If you're there with a parent, ask your parent, what do you think? Did you study alchemy in school, or did you study chemistry? All right, I'm seeing some answers pop in. So we can't turn lead into gold. That's very true. Some people are saying because we don't want people to make fake money. Definitely also true. And because we have elements. Yes. One of the big reasons why we do chemistry instead of alchemy is because we have a periodic table of elements. As technology has improved over the past 200 years, scientists have been able to better understand what our world is made of. Now we know that everything is made from elements which react with each other to form molecules. We even know that elements have protons, neutrons, and electrons. Now we have a new way of understanding how matter works. So we don't need alchemy anymore. We have chemistry, which is the study of the elements. So everyone's seen the periodic table of elements, way more complicated than just the Mercury Sulfur theory, but also a lot more accurate. So it's a good thing we study chemistry and not alchemy, really. So what do you think are some similarities between alchemy and modern chemistry? Let's take a minute and we'll write down some differences, some similarities. I want everyone to think of maybe 2 differences and 2 similarities. And let's just take 2 minutes and write it down. Let's see if I can think of any differences between alchemy and chemistry. Well, let's see. Both alchemists and chemists are studying matter, but obviously we can't turn lead into gold as much as we would like to. So that's a difference. What are some other differences? The periodic table of elements. The alchemists didn't have that. Maybe another difference is that there were lots of different theories. You could be an alchemist, but you didn't have to believe in the Mercury Sulfur theory. You could believe that metals were made of other things, but you could still be an alchemist. Whereas if you're a chemist, you have to believe in the periodic table of elements, and everyone now believes in the elements. So maybe that's a big difference, is that, you know, there's one overarching theory for chemistry, whereas there wasn't for alchemy. So do you guys have your lists? Let's see what I came up with. Okay. So some similarities. Alchemists and chemists both want to understand how matter works. Both rely on experimentation and laboratory work to learn about the way matter behaves. This was a very practical science, and As we saw earlier, there were big laboratories that people were using to understand how matter behaves and experimenting on different metals and different things and their properties. Both alchemy and chemistry are guided by a set of theories which contain rules determining how matter behaves. Matter has to act within these rules. That's why it's not magic. It has to behave according to the laws of nature. Both have a number of practical applications, making medicines, metals, dyes. People study chemistry, but usually they study it with an end to do something else, like make medicines, different things. There's really practical sciences. And now maybe for some differences, well, obviously we can't transmute one metal into another, and chemistry relies on the periodic table, whereas alchemy uses older theories that we know don't work. So this is what happens in science. We'll have a theory, it'll explain some things about nature, but it maybe won't explain everything about nature. And then we get new technology and we are able to learn more about the world. We're able to better understand how things react. And then we get a new theory. And it doesn't mean that the people who believed in the old theory were silly or stupid. It just means that they were using the theory that made the most sense to them with the information they had at the time. And with the information that we have today, we have things like scanning electron microscopes and other technologies that can really break down things, and we can see how the elements are reacting with each other. It's, we have our new theories, and they better explain how the world works. The alchemists didn't have that. They were just sort of going with what they could see with what their technology allowed. So this is how science goes. And maybe someday our theories will seem very old or very silly or strange to people 1,000 years in the future, but that's how science is. So let's transmute a penny. Now that you know all about alchemy, you're ready to become your own practicing alchemist. So now we know we can't actually turn metals into gold, but we can see how the alchemists thought that this was possible. And so for this experiment, you will need a penny. The older and the dirtier the penny, the better. You'll need your salt, your vinegar, a little dish. Please don't use a metal dish. And maybe some paper towels. So first we're going to take our penny. Here's mine. And you can see how dirty it is. It's a really old one that I found under my desk, very old. Maybe it's got a little bit of a green color to it. This is because copper, which is one of the most abundant metals in pennies, oxidizes. And so when it oxidizes, the copper is exposed to the oxygen in our air, and it joins with the oxygen atom to form a molecule called copper dioxide, which can have this brownish, greenish tint to it. So take a dish, place your penny in a dish like this. Let's move this down a little bit. Place your penny in a dish like this. And don't use a metal dish, use a ceramic dish or plastic, really anything that's not metal is good. And you're going to take some salt. And you're just going to lightly sprinkle some salt on top of the penny. That was way too much salt. You don't need a ton of salt, just enough to cover the penny. Now you're going to take your vinegar. And again, you don't need a lot of vinegar. You just actually want to put a couple of drops on the penny itself. And you don't want to use too much vinegar because vinegar can smell. And I don't think the rest of your family wants to smell vinegar all night. So you're just going to take a little bit of vinegar, maybe just 2 drops and pour 2 or 3 drops of vinegar on top of the penny with the salt. And as you watch the salt dissolve, look at the penny. Watch and see what's happening. Do you see how the penny is changing color? Remember how gross my penny looked? Well, now you can see it's becoming a lot brighter. It's turning back to that reddish coppery color. It's good, it's working. So what's going on right now is the salt and vinegar are combining to form a weak acid, which breaks down the layer of copper oxide on the surface of the penny. So it's basically just stripping that layer off and making the penny change color. So now you can take your penny out of your dish. If you have a paper towel handy, take a paper towel and just sort of wipe your penny off between your paper towel. You can also, you should also rinse your penny off, maybe in a little water. So let's just, I have a little cup of water here. You don't have to do this right away, but eventually you'll want to rinse it off or else the reaction will continue. So we'll rinse off our penny, dry it off, and we have a nice shiny penny. Cool, right? Now, if I'd left it in even longer, all of this black stuff on the edge, this is all still copper oxide, that would dissolve as well. So the longer you leave it in, the better your results will be. If you leave it in for like 10 minutes and then really scrub it down with a paper towel afterwards, you'll get a penny that looks just like new. So why don't we all take a moment, clean off our pennies, and then pose for a selfie with the camera. So here's my selfie.
Awesome. And as everyone's getting ready for that selfie, as a quick reminder, don't forget to post your selfies on Instagram and tag us here at Varsity Tutors, as well as the Science History Institute, and you'll be entered to win that swag bag and camp subscription. I'll turn it back over to Megan for just a little more selfieing. All right, wonderful. And if your pennies are still soaking, if you're still finishing up your experiment, or if you didn't get a chance to snap that selfie just yet, not to worry. We're gonna have a couple more minutes here of Q&A, and you're welcome to snap a selfie at any time then as well. We've got some really wonderful questions.
And parents, I just want to say, or whoever is kindly helping you clean up after this experiment, you should add some water to the salt and vinegar solution and pour it down the drain. If the vinegar still smells, you can run the tap for a few seconds. That'll take care of the vinegar smell, because I know you don't want your kitchen to smell like vinegar.
Thank you so much. Awesome. Well, we can't wait to see those results. So do please include them in your selfies if you've been following along with the experiment. Now, you started to address this question a bit, but we had lots of students asking whether people still practice alchemy or whether there are concepts in alchemy that are still applied either in science or perhaps in magic by magicians. So could you talk to us a little bit about that?
Yeah. So there are people who still call themselves practicing alchemists. Most people, not a lot of people do alchemy these days. Most people do chemistry. People who do alchemy still are really interested in making better medicines, but they're not making medicines out of metals. They're making medicines out of plants, and they're just trying to use alchemical principles, alchemical techniques. So, you know, I said there's a lot of laboratory work in alchemy. They're trying to use laboratory techniques to make the medicines safer, more, better for people to use. Yeah, there are still a lot of, actually, like I said, a lot of the practice of chemistry comes from alchemy. So if you go into a chemistry lab, you'll see a lot of glass beakers and things, and a lot of them will look very similar to what I showed you from the Prague laboratory. And this is because chemists use a lot of the same materials that alchemists use. So beakers, test tubes, furnaces, things like this, they were used by alchemists first, and then chemists continued to use them. So really, you can see a lot of alchemy in the modern chemistry lab. And I don't know any wizards or witches, I have to be honest. So I don't know if they are using any alchemy. I'm sure they probably are, but yes, I don't know any personally.
Awesome. All right. Well, that is fair enough. I guess that may be more a question for one of the magicians that we have come up in a future StarCourse, or one that we've hosted in the past. But we also had lots of questions around, other than perhaps just to be a little more mysterious, is there a specific reason why alchemists tended to have these very secretive underground laboratories?
Yeah. So, well, there's a lot of reasons why you would want to have an underground laboratory. You didn't want everyone to know what it was you were doing, right? So not everyone was not everyone had the same theories, not everyone was using the same recipe. And so if you had a recipe for what you thought was gold and you didn't want anyone else to use it, it would be good to have a secret lab space where no one could see you work, because then no one could copy your recipe. It's like, maybe your grandmother has a secret recipe for cookies that she never shares with anybody else, right? She'll kick you out of the kitchen when she's working on that. Yeah, it's the same with the alchemists. If they had a secret recipe, they wouldn't want to share it. And some of them had to work underground because sometimes alchemy was illegal. So if certain kings were worried about people making fake money, they went and made alchemy illegal. And so the alchemists would have to work underground so that the kings didn't see what they were doing. So there were a number of good, also practical reasons. They use stones to build their furnaces, and the stones can get quite heavy. And so you wouldn't want them on a high level of your house. You'd want them in the basement level.
That all makes a lot of sense. So I guess I'm going to have to create my underground kitchen to make sure that I'm keeping a very close eye on my super secret cookie recipes then.
Absolutely.
Awesome. Well, we also had lots of follow-up questions about the experiments, and in particular, whether it works for other types of coins or if there's something very specific about the penny.
There is something very specific about the penny. And well, that's because it's made of copper. And the copper oxide reacts copper oxidizes, and it's a very noticeable, other metals oxidize, but copper oxidation produces that really kind of yucky green brown color. And it's very evident. It's very obvious to see where it's been oxidized, because copper itself is such a lovely red color. And so you can clean other coins using vinegar and salt, but you'll get it looks the best if you use copper, because copper just really cleans up very well, and it's such a striking change.
Awesome. And a somewhat similar follow-up question. We had lots of students who are wondering, what's going to happen if we do use a metal bowl?
If you do use a metal bowl, the acid that you made using the weak acid you made using the salt and vinegar will actually begin to corrode the metal bowl. And so you will get metal ions floating around in the bowl. So one of the things that we didn't do, but you could do, is when you put a penny like this in a solution of vinegar and salt, I said that the copper oxide breaks down, you actually get free copper ions in the solution. And so if you take a metal that is not copper, certain metals but are very reactive, you can actually dip them into the solution and get a little bit of copper plating. So the free copper ions will react with the metal and cover it in a thin layer of copper. So you can actually put a screw or a nail in and pull it out, and it'll have a little bit of copper plating on it. So this acid is very reactive with metal, and so it'll just break down the bowl as well, which you don't want.
Got it. So some potentially damaged cookware and some potentially unhappy parents if we use
yes.
Understood. Now we talked about several different instances of situations where maybe people at one point thought something was magic and then they came to find out, well, it was really just science at play. Do you have any other favorite examples of cases in history where things that maybe used to seem pretty mystical are now fairly well explained by science?
Ooh, that's a really good question. Actually, I can think of one. So everyone knows about magnets, right? And how you put two magnets together and they either attract each other or repel each other. Well, in the Middle Ages, people were very interested in magnets and they wanted to know how magnets worked, basically, and why certain metals had a magnetic attraction to other metals or other stones. So there are lots of discussions in the Middle Ages about essentially how magnets work and how metals can have attraction to each other. And they said, is there something, they wanted to know what it was about the metals that caused them to react this way and why certain metals like iron are much more reactive than other metals like gold. And so they thought, well, maybe there's something in the iron itself. Maybe there's something in the magnet. Maybe there's something in the gold that the magnetic metals are missing. So there were lots of different, people were really, really interested in this. There were lots of different ways of thinking about how this could maybe happen. And now we know how magnets work. So I think that's a pretty cool example,
Wow.
There's nothing magic about it. It's
sure. And like
it's
you said,
just science.
Yeah. And I'm sure there are things that we still think are maybe a little unknown today that we'll have clear explanations for in science in the future.
Absolutely.
Oh boy, well, we also had some students who were wondering whether the experiment can be taken on the Statue of Liberty. And I think I'm gonna take the liberty of saying, maybe don't. I think that they probably don't want us to do that, but very observative of folks to be able to look at that and say, that's why the Statue of Liberty is green. So if you didn't know already, just a lot of copper there.
That is, but that would take a lot of salt and a lot of vinegar.
It sure would.
And a lot of patience. So yes,
I'm
in
sure.
theory, yes, but in practice, maybe not.
All of New York City probably doesn't want to smell like vinegar for the rest of eternity. So perhaps we'd better leave the Statue of Liberty as it is. Well, it is getting to be about that time. We've had lots of really, really wonderful questions, but do you have any final closing thoughts for students who are maybe interested in chemistry, interested in pursuing a career in chemistry, or perhaps just learning a little bit more about the world of alchemy?
I would say just stay curious. There's a lot of things that we still don't know about the world, and science is always changing. And stay curious, ask questions, and never be afraid to ask why. That would be my big thing. Yeah, ask why.
That. Well, thank you so much. Thank you to Megan and to the entire team at the Science History Institute. Thank you for everyone who tuned in who participated in today's experiments. For those of you who tuned in and are interested in taking part in the experiment after the class is over, please keep in mind you can use that same link to check out the class recording and follow along, pause where you'd like to, and use this experiment to get some nice, shiny, brand new looking pennies yourselves. Don't forget, if you took those selfies, you want to post those and tag us here at Varsity Tutors, as well as the Science History Institute. And in the meantime, we hope to see you all in another Varsity Tutors StarCourse soon. Thanks, everybody.